Hi everyone, welcome back to ANR Academy. This is Nepal Eddy sir. Today we are going to discuss cross ladder theorem and then we go for double cross ladder theorem. See the statement of cross ladder theorem first. I am going to select, there is a baseline it is, and I am going to select two cross ladders. One ladder which is of height h1, another ladder it is of height h2. Suppose that these are two cross ladders. This first ladder, suppose that it is of height h1. Next, another ladder, this is h2 having h2 height. Another ladder, it is of height h2. These two ladders are having cross sectional point here, it is P, and from that point of intersection or point of cross section, from that up to the base the height is suppose h. Then the relation between small h1 and h2 is 1 divided by h, that is equal to 1 by h1 plus 1 by h2. This is the statement of cross ladder theorem. Two cross ladders whose heights from the base h1 and h2, and small h is height up to the cross section, then the relation between them 1 by h equal to 1 by h1 plus 1 by h2. Let us see the proof. Assume that here the endpoints of a ladder, suppose this is A and this is B, here it is C and it is D, point of cross section here P, and assume here foot Q. Now I am going to observe the triangles DAC, triangle DAC and PQC. If you observe, DAC right angle at A, PQC right angle at Q, and both the triangles having common angle at C. Therefore, by angle similarity, these two triangles are similar. Also, next I am going to write the triangle BCA. Triangle BCA as well as PQA. These two are also similar. Why? Because BCA right angle at C, PQA right angle at Q, and both the triangles having common angle here, angle A is common. So by angle similarity, the triangles are similar. Now I can write similarity condition, dA divided by PQ, it is equal to AC divided by QC equal to CD divided by CP. Their sides ratio is proportionate. Next, from BCA and PQA, since they are similar, I can write their ratios, their sides are proportionate. BC by PQ equal to CA divided by QA equal to AB divided by AP. And here observe from the figure A to D, A to D, it is of height h1. Next, P to Q, it is of height h. So that it is equal to h1 by h, first result. Next, BC is of height h2. PQ is of height h. This is second result. Now what I am doing, observe. I am going to write h1 divided by h reciprocal of this h1 divided by h. I am going to use this ratio. From these two, h divided by h1. Actually, h divided by h1 I am going to calculate. Why? Because in the denominator part you have h1. So I am writing h by h1. Reciprocal of this, h by h1 become qc divided by ac. qc divided by ac. Next, from these two, I am going to write h by h2. That is qa divided by ac. Clear? I am going to add these two results. H common for both. Inside we get 1 by h1 plus 1 by h2. In the right part, denominator AC is common length, so that you can add numerator part. And in the numerator you have A to Q, then Q to C. From figure A to Q and then Q to C, that is overall length of AC. So here it is of AC. Since common denominator part, I am going to add numerators. Adding numerators, AQ and QC combination, that become AC. AC at C gets cancelled, you will get 1. Therefore, 1 by h1 plus 1 by h2, that become 1 divided by h. This is the proof of cross ladder theorem. 1 by h value equal to 1 by h1 plus 1 by h2. That is, the length of reciprocal of height of cross ladder, height of cross section, that is equal to sum of reciprocals of heights of ladders. h1 is first ladder height, h2 is second ladder height. So hence, by cross ladder theorem, 1 by h equal 1 by h1 plus 1 by h2. Next, let us move to double cross ladder theorem. Here, in double cross ladder theorem, suppose that this is the base, assume that there are two walls of heights h1, here it is of height h2, and I am going to select this is one ladder and this is another ladder next to two ladders. Suppose that third ladder and it is fourth ladder. We are going to discuss double cross ladders. This is first pair and this is another pair. Yes, this is of height h1 and assume that next one it is of height h3, and here this is entire height h2 and only up to here it is, suppose that h4. Total it is of height h2. Here total of height h1. Two ladders of height h1, h3, and here remaining two ladders of height h2 and h4. Now let us observe the points of cross sections. There are 4 points of cross sections. 1, 2, 3, 4. Assume that it is of height small a and it is of height small b. It is of height small c and it is of height small d. Now in case of double cross ladder theorem, the relation between ABCD, that is 1 by A plus 1 by D, that become 1 by B plus 1 by C. This is the result by double cross ladder theorem. Irrespective of heights h1, h2, h3, h4, whatever the heights, here only we get the relation between cross sectional heights. Sum of reciprocals of extreme heights equal to sum of reciprocals of middle cross sectional heights. 1 by A plus 1 by D equal to 1 by B plus 1 by C. That result now we are going to prove. See, with the help of cross ladder theorem, I am going to write 1 by A first. 1 by A, that is cross section of ladder with height h3 and ladder with height h2. So that we get 1 by h2 plus 1 by h3. Just now we discussed about cross ladder theorem. 1 by h is combination of 1 by h1, 1 by h2. So cross sectional height reciprocal equal to sum of reciprocals of heights of the ladders. The same here applicable. 1 by A I am going to write. Here this is the cross section by two ladders of heights h3 as well as h2. So 1 by h2 plus 1 by h3, that is. And you have here 1 by D next. See here, D is the cross sectional height of two ladders. They are of height, one is h4 and the other h1. So here I can write 1 by h1 plus 1 by h4. Now LHS become 1 by A plus 1 by D, that is equal to combination of all the four. 1 by h1 plus 1 by h2 plus 1 by h3 plus 1 by h4. This is LHS part. Now try to find 1 by B first. 1 by B, here B is the cross sectional height with two ladders of heights h3 and h4. So I can write 1 by h3 plus 1 by h4. Next 1 by C I am going to write. See the combination of ladders of heights h1, h2. So I can write 1 by h1 plus 1 by h2. Therefore 1 by B plus 1 by C become 1 by h1 plus 1 by h2 plus 1 by h3 plus 1 by h4. All the four combination. So that RHS, that is 1 by B plus 1 by C, also 1 by h1 plus 1 by h2 plus 1 by h3 plus 1 by h4. This is RHS part. So sum of reciprocals of heights of the ladders for both LHS and RHS, and hence I can write LHS equal to RHS, that is 1 by A plus 1 by D equal to 1 by B plus 1 by C. That is sum of reciprocals of cross sectional heights at the extremities equal to sum of reciprocals of cross sectional heights in between them. So this is about double cross ladder theorem. Remember, irrespective of heights of ladders, there is a relation between cross sectional heights. 1 by A plus 1 by D equal to 1 by B plus 1 by C. And in cross ladder theorem, cross sectional height h and h1 h2 having the relation 1 by h equal to 1 by h1 plus 1 by h2. I hope you have understood everything. The students, those who are watching my videos, please like, share, subscribe my channel, as well as please comment on my videos. Thank you so much.